Hey there, friends! Today we're diving into the incredible world of passive radar, a technology that's like a ninja of the detection world. Silent, clever, and packed with possibilities. Whether you're a tech enthusiast, a curious hobbyist, or just someone who loves learning about cool stuff, I'm here to walk you through what passive radar is, how it works, why it's awesome for home users, and where you can learn more. Picture this as a chat over coffee, where I'm sharing all the juicy details with a big smile and a lot of excitement. Let's jump in. Let's talk about what passive radar is first up. Let's unpack what passive radar actually is. It's like a super smart listener that picks up on signals already floating around us. Passive radar, sometimes called passive bistatic radar or passive coherent location, is a system that tracks objects like planes, drones, or even cars by using radio signals that are already out there, like FM radio, TV broadcasts, Wi-Fi, or cell phone signals. Unlike traditional radar, which shouts out its own signals and waits for an echo, passive radar stays quiet, sneaking around by borrowing signals from the environment. This makes it stealthy, affordable, and perfect for anyone who wants to explore radar without a big budget or a giant antenna tower in their backyard. This stealthy nature is what makes passive radar so special. It doesn't need to send out its own signals, so it's invisible to radar detectors, which is why military folks love it, and why hobbyists like you and me can have fun with it without drawing attention. Plus, it's way cheaper than traditional radar since you're not building a transmitter, just grabbing signals that are already there, like tuning into your favorite radio station to spy on the skies. Passive radar works by picking up two types of signals, one straight from the source, like a radio tower, and another that's bounced off something, like a plane flying overhead. By comparing these two signals, the system figures out where the object is and how fast it's moving, almost like solving a puzzle with sound waves. It's a bit like listening to an echo in a canyon to guess how far away a cliff is, but way more high-tech, and with math that's honestly kind of fun once you get the hang of it. How passive radar stands out from active radar now. Let's chat about how passive radar is different from the classic radar you might picture, like those spinning dishes at airports. Active radar sends out its own radio waves and listens for them to bounce back, but passive radar is like a silent observer, using signals that are already out there, which gives it some unique advantages and a few quirks. One big difference is that passive radar is super stealthy. Since it doesn't emit any signals, it's invisible to devices that detect radar, making it perfect for sneaky applications or just keeping your hobby project under the radar, pun intended. This also means you don't need expensive equipment to send out signals, which keeps costs low and makes it accessible for home users like us who don't have a military budget. Another cool thing is how flexible passive radar is. It can tap into all sorts of signals, FM radio, digital TV, Wi-Fi, you name it, so you can adapt it to whatever's available where you live, whether you're in a bustling city or a quiet suburb. But it's not perfect. Its performance depends on how strong those ambient signals are. So if you're in a remote area with weak radio signals, it might be trickier to get good results, and the signal processing can get a bit complex because of noise or interference. Where passive radar shines in the real world. Passive radar isn't just a cool concept. It's used in all sorts of ways, from high-stakes military operations to science experiments and even potential home projects. Let's explore some of the exciting ways people are putting this technology to work, starting with the big players and then zooming in on what it means for us at home. In the military world, passive radar is a game changer for spotting stealth aircraft. These planes are built to dodge traditional radar by absorbing or deflecting signals, but passive radar uses ambient signals that stealth tech can't hide from, making it a secret weapon for tracking sneaky targets. It's also used for air traffic monitoring without giving away the radar's position, which is super handy for keeping things covert, like watching the skies without anyone knowing you're there. On the water, passive radar helps with maritime surveillance, picking up ships or low-flying objects using signals like FM radio or satellite broadcasts. It's also great for counter-drone operations, catching those pesky little drones that are hard to spot with regular radar because they're so small. Imagine a military base using passive radar to make sure no unauthorized drones are buzzing around. It's like having an invisible guard dog. In the commercial world, passive radar is a budget-friendly way to boost air traffic control, especially in places where traditional radar isn't available. It can also monitor weather by looking at how signals scatter in the atmosphere, or even help with border security by spotting unauthorized crossings in remote areas. It's like giving communities a low-cost way to keep an eye on things without breaking the bank. Scientists love passive radar too, using it to study the atmosphere or track wildlife. For example, researchers might analyze how signals bounce off the ionosphere to learn about space weather, or use passive radar to follow birds tagged with tiny reflective devices, which is a super cool way to blend tech and nature. These applications show just how versatile passive radar is, touching everything from defense to science. Why passive radar is awesome for home users. Okay, let's bring it closer to home. Thanks to affordable tech like software-defined radios, or SDRs, passive radar is now something you and I can play with in our garages or backyards. Here's how hobbyists can use it to do some seriously cool stuff, whether you're tracking planes, spotting drones, or just geeking out on a science project. One fun use is tracking aircraft in your local airspace. With a passive radar setup, you can detect planes using FM radio or TV signals, even ones that aren't broadcasting your position like those you see on apps like Flight Radar 24. It's exciting because you can spot small private planes or even drones that don't show up on public tracking apps, giving you a unique window into the skies above your home. Another great application is drone detection, which is perfect if you're worried about privacy. You can set up a system to catch unauthorized drones flying over your property, using signals like Wi-Fi to pick up their reflections. It's like having your own personal airspace security system, letting you know if someone's snooping around with a drone, all without spending a fortune. Passive radar is also a fantastic educational tool. Building your own system teaches you about signal processing, radio frequency engineering, and radar principles, making it a hands-on way to dive into some seriously cool tech. Imagine setting up a passive radar for a school science fair, showing off how FM signals can track moving objects. It's the kind of project that could inspire the next generation of engineers. You can even use passive radar to monitor vehicle speeds, like cars or bikes near your home. By analyzing Doppler shifts in signals, you can estimate how fast something's moving, which is a non-intrusive way to keep tabs on traffic patterns, maybe for a neighborhood watch group studying a busy street. It's like being a traffic detective, using the airwaves to gather clues about what's happening around you. Finally, passive radar can be a DIY security system for your home. By looking at changes in Wi-Fi or cell signals, you can detect movement in your backyard or driveway, creating a low-cost alternative to motion sensors that's harder for intruders to spot. Picture getting an alert on your phone when someone steps onto your property. It's a sneaky, techie way to stay secure. Challenges you might face at home now. I'd be remiss if I didn't mention that passive radar at home comes with a few hurdles, but don't worry, they're totally manageable with some know-how. Let's talk about what you might run into and how to tackle it, so you're ready to roll with your project. One challenge is that passive radar depends on strong signals like FM radio or TV broadcasts. In urban areas, you're golden with tons of signals, but in rural spots, you might struggle to find strong enough sources, so you'll need to get creative with what's available, like Wi-Fi for shorter ranges. It's like fishing. You need to know where the good spots are to catch the signals you want. Processing all those signals takes some serious computer power, even for basic setups. Modern PCs or even a Raspberry Pi can handle it, but you'll need to be patient and maybe upgrade your hardware if you're diving into complex signals like digital TV. Think of it like running a video game. Your system needs enough juice to keep up with the action. You'll also need a bit of technical know-how to get started. Building a passive radar involves understanding radio frequencies, signal processing, and maybe some coding and tools like Python or GNU Radio, but there are tons of tutorials and communities to help you learn. It's like learning to cook a new recipe simple, and soon you'll be whipping up radar systems like a pro. Lastly, there are legal considerations to keep in mind. Using passive radar to monitor drones or aircraft might raise privacy or regulatory questions in some places, so always check your local laws to stay on the right side of things. It's like setting up a security camera. You want to make sure you're using it responsibly and legally. How to build your own passive radar system, ready to get your hands dirty. Building a passive radar at home is totally doable with some affordable gear and a bit of enthusiasm. Let me walk you through the steps to create a basic system so you can start tracking planes or drones like a tech wizard. First, you'll need some hardware to get started. Grab 2 software-defined radios, or SDRs, like the new Elec NESDR, which are about $30 each, plus some simple antennas tuned to your signal of choice, like FM radio, and a computer like a laptop or Raspberry Pi to process everything. It's like assembling a model kit. You just need the right pieces, and you're ready to build something awesome. Next, pick a signal source to work with. FM radio, which operates between 88 and 18 MHz, is a great starting point because it's strong and widely available, perfect for spotting big objects like planes. If you want to detect smaller things like drones, you could try Wi-Fi signals at 2.4 GHz, but they're trickier to process, so it's like choosing between a hammer and a scalpel depending on your project. For software, you'll want something like GNU Radio, which is a free toolkit for handling signals, or maybe Python if you're into coding your own solutions. These tools let you capture signals, compare them, and figure out what's out there, kind of like being a DJ mixing tracks, but instead, you're mixing radio waves to spot objects. When setting up, place your antennas strategically, one pointed at the signal source, like an FM radio tower, and the other scanning for reflections from your target area, like the sky or your backyard. Then, use your software to filter out noise, compare the signals, and create a map showing where objects are and how fast they're moving. It's like drawing a treasure map, but for planes or drones. A couple of fun examples to try. Let's get practical with a couple of examples to spark your imagination. These are real-world ways you can use passive radar at home, and they're super fun to try out. Imagine setting up a system to track aircraft using FM radio signals. You'd use 2 SDRs tuned to a local FM station, say at 100 MHz, with antennas pointed at the radio tower and the sky, and a laptop running GNU Radio to process the signals and show you where planes are flying, even those not on public tracking apps. It's like having your own air traffic control tower in your garage, letting you watch the skies for hobbyist planes or sneaky drones. Or picture setting up a drone detection system to protect your privacy. Using Wi-Fi signals at 2.4 GHz and a slightly fancier SDR like the HackRF1, you could place antennas around your property to catch reflections from drones, with a Python script alerting you if something's flying overhead. It's like setting up a high-tech fence to keep your airspace secure, perfect for anyone who values their privacy. Tips to make your project a success. Before you dive in, here are some tips to make your passive radar project smooth and fun. They're like the cheat codes to ensure you get great results without too many headaches. Start small with something like FM radio signals, since they're easier to work with and available almost everywhere. It's like learning to ride a bike with training wheels before you try a unicycle, letting you build confidence with simpler projects first. Once you've got the hang of it, you can experiment with trickier signals like Wi-Fi or digital TV for more advanced setups. Spend some time learning about signal processing concepts like how to measure Doppler shifts or filter out noise. There are tons of free tutorials online, and it's like learning the rules of a new game. Once you know them, you'll have way more fun playing with your radar system. You don't need to be a math genius, but a little knowledge goes a long way. Experiment in different environments to see how your system performs. Urban areas might have lots of signals, but also more interference, while rural spots could be quieter but have weaker signals, so it's like testing a recipe in different kitchens to find what works best. Keep tweaking and testing to get the best results for your setup. Finally, tap into online communities for support. Places like Reddit's RRTLSDR or the GNU Radio forums are full of folks sharing tips and troubleshooting advice, like having a group of friends who are all into the same hobby. You'll find inspiration and answers to make your project even better. Where to learn more about passive radar? If you're as pumped about passive radar as I am, you'll want to dig deeper, and there are tons of great resources out there to fuel your curiosity. Let's explore some places where you can learn more, from books to online communities, so you can become a passive radar pro in no time. There are some fantastic books to check out, like Passive Radar by Mikhail Chernyakov, which dives into the nitty-gritty of how it all works. Another good one is Introduction to Radar Systems by Meryl Skolnick, which gives you a broader context with sections on passive radar, perfect for understanding the big picture. These books are like guidebooks for a new adventure, giving you the map to navigate the world of radar tech. Online, you can find academic papers on sites like IWEE Explore or Google Scholar by searching for terms like passive bistatic radar or passive coherent location. Look for authors like Hugh Griffiths or Chris Baker, who've written some awesome papers, like one on using digital TV signals to track aircraft. It's like finding treasure troves of knowledge to deepen your understanding. These papers might feel a bit heavy at first, but they're packed with insights if you take it one step at a time. If you prefer learning through videos or courses, check out YouTube channels like Signals Everywhere or Tech Minds, which have tutorials on using SDRs for passive radar. You can also find online courses on platforms like Coursera or MIT OpenCourseWare that cover radar and signal processing, like a digital signal processing course from EPFL. It's like having a teacher guide you through the techie stuff at your own pace. Don't sleep on online communities either. Reddit's RSRTLSDR is a goldmine for hobbyists sharing passive radar projects, and RARF Electronics is great for deeper dives into radio frequency tech. These forums are like hanging out at a virtual coffee shop with other radar nerds, swapping stories and tips to make your project shine. Tools and events to boost your knowledge. To get hands-on, you'll need some software and tools, and there are plenty of free or affordable options to explore. Let's talk about what you can use and some events where you can connect with other radar enthusiasts. GNU Radio is a must-have. It's a free toolkit for signal processing with tons of examples for passive radar. You can download it from newradio.org and check their wiki for guides, like a recipe book for cooking up radar projects. If you're into coding, Python libraries like PyRadar or MATLAB toolboxes are great for custom processing, and they're like having a Swiss Army knife for analyzing signals. For real-world connections, look into events like the IEEE Radar Conference, where experts share the latest in passive radar tech. Amateur radio events or hackathons focused on radio frequencies are also awesome for meeting folks and learning hands-on, like joining a club where everyone's obsessed with the same cool hobby. Check out groups like the IEEE Aerospace and Electronic Systems Society or the Association of Old Crows for more resources. They're like fan clubs for radar geeks. If you want to see what's buzzing online, I can search platforms like X for recent posts about passive radar projects or SDR setups. It's like checking the pulse of the hobbyist community to find fresh ideas or new gear people are excited about. Just let me know if you want me to dig into specific keywords like passive radar DIY or SDR radar projects. What's next for passive radar? Before we wrap up, let's peek into the future and some things to keep in mind as you dive into passive radar. The tech is evolving fast, and there are some exciting trends and tips to know about. Machine learning is making passive radar even cooler, helping systems filter out noise and identify targets like planes or drones more accurately. It's like giving your radar a brain upgrade, letting it learn from patterns to spot things better, which is super exciting for hobbyists wanting to push the limits. Researchers are already using neural networks to make sense of messy signals, and soon you might be able to use these tricks at home. The rollout of 5G networks is another big deal, offering high bandwidth signals that could make passive radar sharper and more precise. Imagine using 5G to track tiny drones with pinpoint accuracy. It's like upgrading from a flip phone to a smartphone, opening up new possibilities for what you can detect. But it'll need fancier SDRs, so keep an eye on new hardware hitting the market. Some folks are even exploring crowdsourced radar, where multiple home setups work together to create a network for tracking stuff. It's like a neighborhood watch, but for the skies, and it could let hobbyists team up to cover bigger areas. This is still in early stages, but it's a cool idea that might inspire you to connect with other radar fans. One last thing, always keep legal and ethical stuff in mind. Using passive radar to monitor airspace or your property is awesome, but make sure you're following local rules to avoid any trouble, like checking the manual before flying a new drone. It's all about having fun while being a good tech citizen. Wrapping it up with a boso, there you have it, a deep dive into the world of passive radar, from its stealthy roots to the awesome things you can do with it at home. It's a technology that's equal parts science, detective work, and DIY magic, letting you tap into the airwaves to track planes, guard your privacy, or just learn something new. With affordable tools like SDRs and software like GNU Radio, plus a vibrant community of hobbyists, you've got everything you need to start your own radar adventure. If you're itching to keep going, I can search X for the latest passive radar projects, whip up a detailed tutorial for building an FM-based system, explain the techie bits like signal processing in more detail, or even create a visual to show how arrange. Doppler map works if you give me some specific data. Just let me know what's next on your radar, see what I did there, and I'll be here to keep the conversation going.